Hello, my name is Gunwant, and today's my topic is the photobiological process in which the bacteria rhodospin, and I am from group 316. The rhodospin is a protein found in the red helicobacter plays a crucial role in the transport of the proton across the membrane against the pH gradient. It is composed of one protein molecule attached to a retinal molecule view an aluminum bond with and has a molecular mass of 26,000. The helicobacteria are external halophytes that can grow in the saline lakes uh, and have a positive photo access to the visible light and a negative photo access to the ultraviolet light. The bacteriorhodopsin functions as for photo-induced proton pump transporting proton across the membrane against the pH gradient. The operation of this pump is coupled with the phosphorylation uh, of ATP and the operation of sodium pump, which provide the desalting of the internal medium of the bacterial cell. The Mitchell theory could be applied to this system. Now, the purple membrane of bacteria is crystalline rather than liquid, with the bacteriorhodopsin molecule assembled into clusters and packed into a hexagonal lattice. Each molecule contains 7 rods like alpha helix 3.5 to 4 nanometer long, oriented perpendicular to the membrane plane. The bacteriorhodopsin runs through the entire membrane and comes into contact with aqueous phase on both sides of the membrane. The photo-induced proton transport involves changes in the formation of bacteriorhodopsin and its spectrum. The light-adapted form Br5070 enters the cycle of photo-induced reactions, giving rise to the intermediate compounds. In one revolution of cycle, upon absorption of one light quantum, one proton is passed through the membrane. The Chernyshevsky and the Chernyshevsky in 1978 examined this process on the basis of tunneling transport of electron leading to an intramolecular transformation of energy. The model consists of the two potentials well separated by a barrier representing electrophilic groups. The proton approaches cause well second to the become polarized, lowering its electronic level, while one being positively charged also become polarized, raising its level. Conformational changes leads to the relaxation to a new equilibrium state with a new charge distribution. The electron reverses tunneling from well second to lower level, repeating polarization and conformational relaxation. The cycle ends with some resonance conditions provided by polarization and conformational transition. The process of electron tunneling involves the proton approach to polarize well second, leading to a lowering of electronic level. This is followed by a rise in well 1 due to the conformational change, resulting in a new equilibrium state with a new charge distribution. The cycle is terminated by reverse tunneling of the electron from well second to the lower level of well 1, followed by repeated polarization and the conformational relaxation. Now this is a diagram the function cycle of the bacteriorhodopsin, and this we have discussed the two electrophilic groups separated by an energy barrier. This is second and this is the first. Now the free energy change of the proton upon the tunneling from 1 to second is given by, like this is the equation. We have this value where E equal to 4.8 into 10 to the power minus 10. So is the electronic charge. That is equal to 5 is the dielectric constant, where R2 is the distance from the proton to the center of the second, and at is the distance of the center of well 1. For a proton near the nitrogen atom of the sniff base, the dissociation constant changes by 1 to eV. This change in pK on reverse tunneling is one of the same order of magnitude but of opposite sign. The lowering of electronic level for polarization is expressed in a similar manner. This is the second question. In this equation, where R1 and R2 are distance from the proton to the center of the well, and before and after polarization, at R2 equal to 0.25 nanometer and R1 is equal to 0.15 nanometer, that we find that the E equal to 0.75 eV, and this the shift of the level caused by the conformational change are of the same order. This approach of the level requires for the reverse process this can be accomplished. Now here my complete. Thank you.